Okay, for the t-distribution problems here, because almost all of this is using the calculator, I'm going to leave up the calculator for most of this video. I'm going to clear things out so that you can see what's going on here. All right, I'm at the main screen. The first problem says, suppose you take a sample of 100 high school students and find that on average they spend $11 at Chipotle during a visit with a standard deviation of 75 cents. What is the 95% confidence interval for the average spent at Chipotle during a visit for the entire population of high school students? So we go stat, test, and for this entire worksheet you are using the t interval. Okay, we're always doing stats, we're not doing data. The mean that was presented in the problem was $11. The standard deviation that was presented in the problem was 75 cents, and the sample size was 100 with a confidence interval of 0.95. And we calculate, and that gives me the confidence interval between 10.851 and 11.149. So that is the answer to problem number 1, is that interval. So we believe that the mean of the entire population has to be between like 10.851 and 11.149. Now, part 2 asks me to redo this, but to do this with the increasing the sample size from 100 to 200. So remember here our confidence interval is around 10.85 and 11.14 or 11.15. And then if I do the confidence interval again, but I change the 100 to a sample size of 200 and I calculate it, you're going to notice that my confidence interval went from 10.85 to 10.89. And then on the other end, it went down from 11.15 down to 11.11. So the confidence interval as the sample size is increasing is getting smaller, which makes sense. If I take a larger sample, my sample is getting closer to the population. All right, so problem 3 says, okay, go back one more time and change the sample size back to 100, but change the confidence level from 95 to 90. And again, what happens is that this interval is smaller than the first one. The first one was 10.85 to 11.15. This one decreased down to 10.87 and 10.88, down to 11.2 or 11.3. So another way to make the interval smaller is to be less confident. If I want to be more confident, I have to make the interval larger. All right, so let's look at number 4. Number 4 is a whole new problem, right? So again, we're going to build a confidence interval here, the t interval. There we go. In this problem, they say that the mean of the American household is 56,516, right? The standard deviation was 2,412. And they took a sample size of 4,000 American households with a 95% degree of confidence. So when I calculate that, it tells me that the actual mean for households is between 56,441 and 56,591. Okay, so not so bad. So they say, well, what happens if we add the Bezos family into this, right? So when we do the Bezos family in number 5, it says we're going to change some of our data here. The mean moves from 56,516 to 56,922 and 23 cents. The standard deviation moves from 2,412 to 25,695.42, and the sample size gains 1, right? Because we just gained the Bezos family. All right, so what happens to my interval? Couple things happened here. One, the interval just got way wider, and that's because the standard deviation is huge. The second thing is this interval shifted way to the right. So is it problematic if we include the Bezos family? Sure it is. They're what we would typically consider to be an outlier. Their income is way outside of what we would consider the normal range here, and they're causing all sorts of problems. The interval is getting huge. We're shifting to the right. These kind of things would be problematic if they happen to get picked up in a sample of average Americans. All right, so number 6 starts a little bit of a thing on grade point average. Let's take and start a new t-interval, right? In number 6, the mean GPA here was 3.49. The standard deviation was 1/4 point, 0.25. And we took a sample of 89 students with a 95% degree of confidence. And that gives me an interval between, so the actual population had to have a GPA, an average GPA between 3.44 and 3.54, right? So there you go. Okay. Number 7 is a similar problem. So NCES took a random sample of 400 American high school students, and they found that these students had, let's get the test up here, or T interval, right? Had a mean of 3.0 with a standard deviation of 1/2 point. And they did this as a sample of 400 students. So we want to create the 95% confidence interval. So this was in 2007. The interval, the mean had to be between 2.95 and 3.05. So 2.95 to 3.05 in 2007. In 2017, they repeated the sample. And so 10 years later, the mean in that year was 3.38, and they had a standard deviation of 0.31. The number in the sample was still 400 with a confidence of 95%. So this time the interval goes to 3.35 to 3.41. Now if you look at the two intervals, you look at the one in problem number 7 and the one in problem number 8, we can use those to answer the question number 9. Number 9 says, can you say that there is a statistically significant difference between the two averages? And the answer is yes. Because if you look at those two intervals, there's no place where they overlap. So at no point do those two intervals overlap, which means that there's a statistical difference between the mean of GPAs in 2007 and the mean in 2017. GPAs were higher in 2017 than 2007. Now, what do you think is causing the difference between these? That's something that's a subjective question at this point, but it's one that's worth, since it's statistically significant, we can dive in and determine whether or not it's practically significant. Viable answers might be that kids are getting smarter, might be that kids are becoming more grade conscientious, might be that it's just easier to get higher grades, that there's some grade inflation going on in the schools. Whatever answer you've got there, as long as you provide a good reason, you're in good shape. All right, so there you go. These are the t-distribution problem solutions. I hope you're well. I hope you're healthy, and I hope this is helpful. If you've got questions, email, hop into one of the drop-in sessions, and we'll see if we can get you some help. All right. Thank you.